Hello everyone, welcome back. Today we're going to try to finish our topic in triangles and trigonometry. So next week we're gonna start a new one. So I'm trying to go a little bit fast, but still like you can understand me. So just get to it since we're just missing like 3 pages more. So let's go. Jeremy rides his bike to his friend Khalil's house. If he takes the road, he rides 3.6 mile east. So the road, I like to write everything. So the road is 3.6 miles. And then 1.5 miles north. There is also a path that goes through the woods directly from Jeremy's house to Khalid's house. For 8. To the nearest degree, what is the angle shown between the road and the path? Okay, this we just use the SOHCAHTOA, you know. And here we have the opposite and the adjacent. The opposite, the one opposite to the angle, the adjacent, the one that is right next to the angle, and it's not the big line, the long one. Oops. Because the long one is the hypotenuse. So we don't want that. So we have opposite and adjacent, and we know the TOA. So tangent of the angle going to be equal opposite, which is this one, to the adjacent. Now we're looking for the angle. Okay, let me make it a little bit smaller on the side. So we're looking for the angle. Oops. So I can say that the angle will be equal to tangent -1, or the arctangent of the ratio. So 1.5 over 3.6. This is only when we're looking for the angle. So I'm going to my calculator and putting tangent -1, 1.5 over 3.6. And here I get an angle of about 22.62 degrees. So my angle is approximately 22.62 degrees. Yep. Oh, my bad. They're saying to the nearest degree. Be always very careful with that. So if it's to the nearest degree, we don't want any like point or decimal, so we just round the number. So 6 is greater than 5, so the answer will be 23, rounding to 0 decimals. Now for B, to the nearest tenth of a mile, how much farther is it to go by the road than to go through the path? Okay, we want to know the difference between going using the road and the path, but for that we need to know the measure of the path. So here I'm going to use my beautiful Pythagorean theorem. So I have one side, so A, I have side B, and I use the big line, which is going to be C, like the hypotenuse. Like how they tell me the theorem here, how they tell me the theorem, so I didn't get confused. What hypotenuse square is equal to catet 1 square times catet second square, or side 1 square times side 2 square. But it's just like the hypotenuse is the one. So I will say C squared equal A squared plus B squared. And I'm looking for the hypotenuse, like for the big line. So that's C. So I know that the side I'm looking for is going to be equal to the square root of A squared plus B squared. Now I just substitute the values and I get, square root 8.6 squared plus 1.5 squared. And C is approximately, can just go to my calculator, put the square, I put 3.6 square plus 1.5 square, and I get approximately, I'm going to round it up like to give it with some decimals more than we need for now, just to round better later. So it's 15.426. So I just round it up this one, this one. Oops. So 15.426. And I get approximately 42.6. Right, yeah. So now they're asking by how much farther is to go through the road than to go through the path. Did I put it right here? Oh yeah, this just makes sense. I put 15 instead of 1.5. Okay, now we get an exact number. This is a lot better. Every time you get a weird number, like if we keep continuing working with it, we're going to get a negative. And we don't want a negative to the answer. Like we know this needs to be smaller than the addition of these two sides. So it needs to be bigger than the addition of those two sides. So the difference is positive. Like this is shorter. Diagonal paths are shorter than doing this whole trip. So yeah, that didn't make sense. Now I put 1.5. I get 3.9. That's C equal 3.9. So the difference will be 3.9 minus the whole row. And the whole row will be the sum. Oh wait, is actually the opposite. Is how much farther. So it's to go by the row. So it's the row minus path because the path is shorter, as I just said before. So it's 3.9. Oh, 3.6 plus 1.5, which is the whole row, minus 3.9. So this is 5.1 minus 3.9. This is approximately, like this is 1.2. And they say to put it to the nearest tenth, and the nearest tenth is, 10 is just 1 0, so it's one number after the decimal. So 1.2. Yeah, we have our answer there. Let us continue. We want to finish this. So showing there and below, a symmetrical roof frame rises 4 feet above the house and has a width of 24 feet. Demonstrate and state to the nearest degree the angle of elevation of the roof frame. Enter your answer in the box. So the angle of elevation, this is going up here. So angle of elevation is just this angle. So I'm just trying to make it pretty. Not working. So I want to know this angle. Now we know the height is 4, so I can put here, like right in the middle. I can say this is 4. And since this is symmetrical, this is symmetrical, both sides are equal. So this means that this line right here is dividing this in half. So this is 12, this is also 12. Now if I want to know the angle, I can see that I have the opposite and I have the adjacent. This is just my identical trigonometry, is TOA, like the soccer TOA. So tangent of the angle is equal, tangent of the angle is equal opposite over adjacent. So the tangent of this angle will be equal 4 over 12. Now, if I want to calculate the angle, I know the angle will be the tangent to negative 1. And now 4 over 12, I can leave it like that, put it in the calculator. If it's just easier for you, you can simplify it. So 4 divided by 4 is 1, 12 divided by 4 is 3. So the tangent to negative 1 over 3. So the angle will be approximately, go here, tangent, oh wait, yeah, oops, tangent to negative 1 over 3 It's approximately 18 times 40, 0.48. 43, not 48. Yeah, 43. Now, do they say to the nearest angle? You always in every single question you need to look for that, so you can know where to simplify to. So if it is to the nearest angle, 4 is less than 5, so it just stay as 18. Now let's go to 40. Each wire that supports a 300-foot radio tower forms a 51-degree angle with the ground. Okay, we already have the figure here. We don't need anything more from that. Now, find the distance from the base of the tower to the point on the ground where the wires are secured, which is already, it's already labeled here. Round your answer to the nearest tenth of foot. Now, I have an angle, and I say this is the opposite, and this right here is adjacent. So again, tangents, toa, tangent of the angle, which in this case 51, will be the opposite, which in this case 300, over the adjacent, which is x. So if I multiply both sides by x, this one here cancels, and I get x tangent 51 equal 300, and I can divide both sides by tangent 51. And this cancel, and I get that x equal 300 over the tangent 51. Now I just go to, we're looking for the nearest tenth of the foot, so it's one number after the decimal. 10 only have one zero, so one number after the decimal. And I go to my calculator. I'm gonna say 300 divided by tangent of 51. And we're looking for 1 point after the decimal, so it is this one. Oops, the first point. So it's 200, 242.9, which is B. Now let's continue. 41. A tipping platform is a ramp. There's no trucks, blah, blah, blah. Show the diagram, blah, blah, blah. The truck is in a 75-foot long ramp. So this ramp right here is a 75 foot or feet, I must say. And it is deep at an angle of 30 degrees. So this angle is 30 degrees. Now, what is the say height of the upper end of the ramp? X, which is already labeled. We want to find X. Now I have an angle. I have the opposite side, and I have the long one. And the long one is the hypotenuse, the one opposite to the 90 degrees angle, to the little box. So I have opposite and hypotenuse, which is so. So, I'm sorry, that was funny for me. So I can say sine, which does the S, so sine of the angle equal opposite over hypotenuse. And the opposite is just the X, and the hypotenuse is 75. 75. And the angle is 30. Now, I can just say, I can multiply both sides by 75, and I get that X equal 75 sine of 30. And I go to my calculator. You say 75 sine of 30, which is 37.5. Now, another way to do it is that if you remember our identity 3, 30, 60, 90, we know that this angle is 30, this one is 90, so therefore this one is 60. And the short line, it's like this. Oops, The short line is half the long line. So we have the long one, which is the hypotenuse, and we need the short. So we just need to divide this by 2. And we're also going to get 7.5, which is the right answer. So you can use whichever comes to your mind. Now, in the diagram below, SBC is it's not congruent, but it's similar. It's similar to SMJ. So S is similar to C, B is similar to M, and C, which is DC, is similar to J. So this is what we have. Now we know that the cosine of J is 3/5, so cosine, so K, so it's adjacent, which is the one right here. So this is gonna be 3. And then hypotenuse, which is the long one opposite to the 90 degrees, so this one is 5. Now, what is the measure of S to the nearest degree? Now, we're looking for the measure of S, and S is equivalent to C. So what I would do is just calculate the measure of this angle so I can calculate the measure of C, which is the same as S. So I have the cosine, I just already say it, so I can say that the cosine of the angle is 3/5. So the angle will be the cosine to the -1 of 3/5. So I go here, I'm gonna come cosine 3/5. And it's about 53 degrees. Yeah, the nearest degrees of 53 degrees. Now that's J. And I'm looking for C because C is the one that is equivalent to S. Every time we see they are in order of equivalency, the letters must be in order. So I have 53 and I have 90, so I could say 180 equals C plus 53 plus 90. So that will take me to 100. I'm just gonna write it all over here. So 180, 53 plus 90 is 100, like C plus 143. Then I subtract 43 from both sides and I get that 37 equals C. So that's my answer, 37. Because C is equivalent, so it's the same angle. Now let's see 43. We need to hurry a little bit. So Marisol backyard is shaped like an isosceles trapezoid. So here's the clue. Isosceles trapezoid. So we already know that this side is going to be equal to this side. Like they already said, like they labeled in the figure. But like it's something that is going to help us later. So now find the distance h between the two parallel sides of Marisol's backyard. Round your answer to the nearest foot. Now, sorry about that. We can do this. They're equivalent. So right now, this is also for me at 90-degree angle, and we have two angles that are equal. This is 64, 64, this is 90, this is 90, and this side is equal to this side. So these two angles, because of the AS, the angle side theorem, are congruent. So therefore, this side H will be equal to this side H. Now, right here, I have a rectangle because I have 90 degrees, 90 degrees, and here there are also 90 degrees, 90 degrees. So this side, this 70, is equal to this side that I have here, which is 110 minus these two little sides. So I can name this side X, name this side X. So I can say that 70 is equal 110 minus 2x because I have two little sides. Now if I solve for x, I can add, I can add x to both sides and subtract 70. This cancels here, and this cancels here. And I get 2x equal 40 because 110 minus 7 is 40. And then I divide by 2 both sides and I get x equal 20. So I know that this side right here is 20. And I have everything we need. As I said before, I was tagging before, we're looking at an opposite and an adjacent. So this is O, this is A. What we have is TOA, so tangent. Tangent. Now, I can say tangent of the angle, which is 64, so tangent of 64 is equal opposite, which is h, times over the adjacent, which I just calculated, and it's 20. So I multiply both sides by 20, and I get that 20 tangent 64 equal h. So I go to my calculator, I put a 20, I put tangent 64, and I get approximately 41. So h is about 41. Here is our answer. What do you want to do in nearest foot? Nearest whole number. Now let's continue because we want to finish this. We need to finish this. So let's read, inscribe, and circumscribe circles at a triangle. So first row, inscribe, inscribe just means that they're inside the triangle. And circumscribe means that they are outside the triangle. The triangle is right in the middle. Now, for which line you must find the intersection? Wait. In order to find the circumcenter of a triangle, for which line must you find the intersection? So, first of all, if we're talking about the circumcenter, it just means that the circle is circumscribed. They start the same, so you can kind of associate them. So on the circle, and if the circle is circumscribed, it means it's outside. Then we need to find the perpendicular of the triangle, the perpendicular bisectors of the triangle. So if we have a rounded triangle, like this, we want to find the circumscribed circle. So we're going to write the perpendicular triangle, which is 90 degrees. Then this one, which is 90 degrees, and then supposedly this one, oops, okay, this will be 90 degrees, and then this will be the center of the triangle. So we just put the thing to draw circles. I forgot the name in English. I'm so sorry about that. So I will put it in one of the, on the vertices, and we draw our circle, and it's supposed to be circumscribed. So right now the answer here will be perpendicular bisector of the side of the triangle. Yep. Now let's go to 46. Yeah, I'm sorry about 45. It's just that it's something that is by memory. There's no other way to do it. So sorry about that. But there's no way we can do this. How the this is. And they don't give you that in the formula sheet, so you better know. And now, oh wait, just an calculation. It's not like it is going to be 20% of the test. So in case you guys don't know, just focus on what you struggle the most. But if you want to get a good score, yeah, you should know for sure all those little details. But at least one or two questions are going to be like that. So let's continue. Olivia is constructing the circumscribed circle of a triangle as shown in the diagram. Okay, what should be the next step of the process? So the only thing she have done is, oops, draw, draw this perpendicular bisector. So to draw this, you step in this side, make an angle here, then went to the other side, with the compass. I know that the name in Spanish is compass, but like in English I'm not sure. Well, with the thing to draw circles, and then make a mark here, make another mark here, and then just draw a line so that is the bisector and it's also perpendicular to the um triangle on the side. So yeah, and then you may decide, so she should do the same for the other one, so for B and C. So let's see, consider the perpendicular bisector for, okay, consider the angle bisector for A. Angle bisector has anything to do with circumscribed circle, so no. Consider the perpendicular bisector for BC, kind of what I just said, so I like it. Set the compass with to AB, then draw a circle with center point A. No, that doesn't even make what we want. We want a circumscribed circle. And the center point shouldn't be one of the vertex. That should be like the the circumference. So set the compass with to BC, then draw a circle with center point C. Again, the same. That's not what we're looking for. That has anything to do with what we're looking for. That would just be something like this. So definitely no. So therefore, yeah, we need to construct the perpendicular bisector for BC. So let's say this. The first step to construct a circle inscribed in triangle PRQ are shown. Okay, this is an inscribed circle, so the circle should be inside, like this, but inside. What they did for the step is just take the compass, put in a specific width, and make a mark here, then put the compass in this point with the same width, and make a mark here, then put in this point with the same width, make a mark here, and then draw the line with the ruler. Now repeat the process here, put a random width. We can leave the same way, we could change it a bit. It doesn't matter. You just need to stay like the same one within the 3 steps, like 4 steps. So make a mark here, then second, make a mark here, then put it here, make a mark here, put it here, make a mark here, and draw the line. So in this specific step, it needs to be constant. And now the intersection point is going to be the center of the circle. So we just put the compass, like the center of the compass here, put it at this way, width, width, and then draw the circle, and it should be like this would be better. So Laila and her friend Devon made the following claims about how they can identify the next. It's supposed to be next. I don't know what happened there. Okay, let me put it in black. So next, whatever. A step in the construction. So Laila used the fact that the radius drawn to the point of tangency of the perpendicular to the point of tangency is perpendicular to the nearest okay, I'm blind. Let me read this again. Laila used the fact that the radius drawn to the point of tangency is perpendicular to the tangent line of the circle. Okay. Then They use the fact that the radius drawn perpendicular to the chord bisects the chord. Complete the sentence to create a statement about who is correct. So, Leila or Davon is correct because this fact can be used to determine the length, okay, of the circle by constructing a perpendicular line from, okay, to any side of the triangle. Okay, now what they're saying like is a property of the inscribed circle. Let me draw it like actually how it should be. So little bit bigger. More or less like that. See that is complicated. You know, more or less like this. So one of the properties is that point, like there are lines running from here, like the radius from here to here, perpendicular, then right down, perpendicular, then this up, perpendicular. So let's see who is saying that. Leila used the fact that the radius drawn to the point of tangency is perpendicular to the tangent line of the circle. So the radius is perpendicular to the tangent line of the circle, and the tangent line of the circle will be something like this. Yeah, that's actually it should be the just weird because I'm not doing it with the actual compass, so like it's difficult to see. Use the fact that the radius drawn perpendicular to a chord bisects the chord. And no, it does not bisect the chord. Like if this is not like this is not in half, like you can see it like really good. That this side is bigger than this side. So yeah, like you can easily see that it's not bisecting. As I have explained before, bisecting is that it divides the chord into equal sides. So this side is a lot bigger than this one. So yeah, that's not true. So we get the Layla. Layla is the one that is true. Let me do it in this color. So yeah, that is true. Now let's see why. Okay, because this fact can be used to determine the length of, okay, this fact can be used to determine the length of the radius, I will say. I'm sincerely not 100% sure about this one. But because we can with the right calculation, the right data, we can do both with that fact. But I think that in the east part is just like the length of the radius. So like that's the easiest one to do because it's right here. Like you don't need to know the specific like angles here to calculate that one. Like to calculate this, but you do need them to calculate um you know the the like the core because it's a long process. So it is a radius because for the core you need more data. So of the circle by constructing a perpendicular line from point C or G to any side of the triangle. So I just draw it. Like you can see right here, this is point G. This is the center of the triangle. C is just like a random point that is not even. Oh wait, a random point that is even inside of the circle. I don't know what I said center of the triangle, but circle. So that's a pretty easy one. It's not C, of course, so if you it's the center of the circle. So yeah, we are just missing one. So okay, this is more or less the same. So complete the sentence about the diagram show. Okay, this I already spoke about this, I think, in a 4, 5, 6 weeks ago. It's like pretty long ago. So this is clearly the figures of an angle bisector, because we put the compass here, we put in a like in a random width, like or less over 3 or 3 4 1 4 or like 1/3 of the whole side. So we put in a random way. So we do this in one of the sides. We then do it in the other side, and we put the compass here, and with the same width, we do a mark here. Then we put it here, and we do the same mark, and then we can draw the line over here through the intersection point of the two lines, more or less like that. And therefore, this angle is going to be equal to this angle. That's how we do it. So this part of the construction of an angle bisector, as I was just saying. For the perpendicular, you saw that is we put for the perpendicular, put this here, put in a random like width. I'm gonna delete this so you can see. And we do a mark here, then we do a mark over here, put the same here, do the mark, and we do the mark, and then we pass the line through. Oh, we put the width on, it's not a random width, it must be the width of the line. So it is perpendicular. So it is bisector. So yeah, it is an angle bisector. So it's needed to construct okay, an angle bisector is the inscribed circle of the triangle. A perpendicular bisector is a circumscribed circle of the triangle. This is just like, this circumscribed, this is what we did in the first two, and then the inscribed is what we did here, which is with the angle bisectors. So yeah, that's all for today. I hope you guys understood. Don't forget that any question you can go to the description channel. I'm basically looking for any question there so I can answer and help you. So yeah, that's all. See you guys next week. Bye.